Hello friends, myself R.D. Mahajan presenting my video on Fourier Series Revision Part 4. Find half range cosine series for the function. There are two values for the function. The first one is 1 by 4 minus x between the limits 0 less than x less than 1 by 2, and the second value is x minus 3 by 4 between the limit 1 by 2 less than x less than 1. And therefore, as we require to find half range Fourier series, it is given by a0 by 2 summation of an cos n pi x by L, n changes from 1 to infinity. We call this equation 1, where the value of Bn is 0, as we require to find cosine series, half range cosine series. Comparing this range with 0 to L range, we get the value of L as 1, where A0 is given by, formula is 2 by L, integration from 0 to L, f of x dx. Substituting the value of L, we get 2 by 1, integration from 0 to 1. But 0 to 1 is not a continuous range, therefore we keep this fx as it is. In next step, we have to split this. Therefore, it is 2, integration from 0 to 1 by 2. In that, function is 1 by 4 minus x, and its integration with respect to x, and plus next one is 1 by 2 to 1, value is x minus 3 by 4, its integration with respect to x. Integrating each term with respect to x, we get 2 times. Either we can integrate it directly, or we can integrate individual terms. Therefore, integrating individually, we get 1 by 4 x, integration of x is x square by 2, and limits from 0 to 1 by 2. Integration of this second term with respect to x, integration of the first one is x square by 2 minus 3 by 4, integration of dx is x, and limits from 1 by 2 to 1. Substituting the upper and lower limit, we get 2 times. First, I will substitute the upper limit as 1 by 2. Therefore, 1 by 4 times 1 by 2 minus 1 by 2 square, it is 1 by 4, and divided by 2, minus lower limit x is 0, that both the term becomes 0, therefore minus 0. Then for the second term, upper limit as 1, therefore we get 1 square as 1 by 2 minus 3 by 4, minus lower limit as 1 by 2, therefore 1 by 2 square we get 1 by 4 divided by 2 minus 3 by 4 into 1 by 2. Simplifying it further, we get 2 times 1 by 4 into 1 by 2, we get 1 by 8 minus 1 by 8 plus 1 by 2 minus 3 by 4, LCM is 4, Here it is 2 minus 3. 2 minus 3 we get minus 1 by 4 and minus we get 1 minus 3. This one is 0. Minus 2 by 8 means minus 1 by 4. Minus minus become plus 1 by 4 and minus 1 by 4. That sum is 0. And therefore value of A0 is 0. If the problem is asked for 6 marks, 1 mark for the formula, 2 marks for finding the value of A0, then we require to find AN. AN is given by 2 by L integration from 0 to L fx multiplied by cos of n pi x by L and its integration with respect to x. It is equals to L is 1, integration from 0 to 1, fx we keep as it is, and cos of n pi x, its integration with respect to x. Then splitting this, we get 2 times. First integration is from 0 to 1 by 2. Value is 1 by 4 minus x into cos of n pi x dx, and plus second 1 by 2 to 1, and function is x minus 3 by 4 into cos of n pi x its integration with respect to x. Then integrating both the terms with respect to x by generalized part, therefore it is 2 times first function is 1 by 4 minus x, integration of second sine of n pi x by n pi, then minus derivative of this term with respect to x minus 1, next integration of sine minus cos of n pi x divided by n square pi square. Next derivative 0, we stop here, and the limits from 0 to 1 by 2. Then plus integrating second term with respect to x by generalized part. First term is x minus 3 by 4, integration of cos sine of n pi x divided by n pi, then minus derivative of this term with respect to x, it is 1, integration of sine minus cos of n pi x divided by n square pi square. Derivative of 1 is 0, we stop here, and limits from 1 by 2 to 1. Substituting the upper limit, uh, 1 by 4 minus 1 by 2, x as 1 by 2, we get that term as sin n pi by 2 whole divided by n pi, then minus 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 3 times minus, that term becomes cos of n pi by 2 whole divided by n square pi square minus lower limit x at 0, this term becomes sin 0, and we know the value of sin 0, it is 0, minus cos 0, is 1, therefore it is 1 upon n square pi square. Then for the second term, upper limit as 1 minus 3 by 4, sin of n pi, sin n pi is 0, minus minus it becomes plus, it is cos of n pi divided by n square pi square, then minus lower limit x as 1 by 2, therefore we get 1 by 2 minus 3 by 4 sin of n pi by 2 divided by n pi. We have to substitute very carefully all the values, upper limit and lower limit. Minus minus plus cos of n pi by 2 whole divided by n square pi square. And then simplifying it, we get an is equals to this 2 times 1 by 4 minus 1 by 2, 1 minus 2 minus 1 by 4 sin of n pi by 2, sin of n pi by divided by n pi minus cos of n pi by 2 divided by n square pi square, minus minus it becomes plus 1 by n square pi square. This one is 0. The value of cos n pi is minus 1 raised to n divided by n square pi square minus, again LCM is 4, 2 minus 3, 2 minus 3 is minus 1 by 4 sin of n pi by 2 whole divided by n pi, and minus cos of n pi by 2 whole divided by n square pi square. This is plus sin n pi by 2 divided by 4 n pi, and this is with minus sign, therefore this term cancel with this term. Taking LCM as n square pi square of 1 plus minus 1 raised to n and minus 2 times cos of n pi by 2. This is the value of an. 2 marks for this all steps. Then substituting the value here in equation 1, we get the required Fourier series. F of x is equal to value of a0 is 0, therefore this term becomes 0. Summation from n equals to 1 to infinity. Value of an is 2 times 1 plus minus 1 raised to n minus 2 times cos of n pi by 2 whole divided by n square pi square into cos of n pi x as required half range cosine series. This is the required half range cosine series for that given function. If you like my video, please share it as well as subscribe to my channel. If you are not subscribed yet, subscribe it, and to receive the notification for all my new videos, you have to press the bell icon. Thank you. Thanks for watching.